This is the practice test for Unit 8, and all of the problems are going to be based on the Pythagorean theorem, whether they use a right triangle directly or using the distance formula or different things like that. It's all based on the Pythagorean theorem. So as always, make sure you show all your work and thinking and circle your answers so it's very clear what you are indicating the answer is. So the instructions on this part say find the missing side of the following right triangles. It does say they're right triangles, so that's good to know. Leave your answer in simplest radical form and include units. So no decimals on this unless they tell us that we're going to write it in decimals. So notice what we've got here. We've got an A, a B, and we're missing a C, so we're missing the hypotenuse. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. So that means leg squared plus leg squared equals hypotenuse squared. So we're going to do 16 squared plus 10 squared equals hypotenuse squared. So 16 squared is 256. 10 squared is 100. That would equal c squared. So this is going to be 356 equals c squared, and then we're going to take the square root. Now that is nasty. That's not much fun at all. But let's think about this here. 2 would go in there. Let's see, if we grab our calculator, so you can always use a calculator here. So let's do 356 divided by 2. We get 178, and we can divide that by 2 also. So you get 89. So this would be 178, and then you get 2, and you get 89. Now there's something interesting about 89. 89 is a prime number. We're not going to be able to break that down anymore. So what we have here is c equals, we'd have a square root, and we'd have a 2, and an 89. So we've got a pair of 2's. So c on this one is going to be 2 radical 89. And then we want to label this. So this is going to be meters. So we'll put an m on there, and there's our answer. Okay, taking a look at the next one here, we're missing this leg, so I'm going to do a leg squared plus a leg squared equals a hypotenuse squared. So this is 121 plus x squared equals 256. Again, if you need your calculator to get those, it's just much easier if you already have these memorized. So I'm going to go ahead and subtract the 121. Calculator's totally okay here. If you grab your calculator, this will tell you that it's 135, and we're going to take the square root. So let's see what we've got for a 135, and I am going to use a calculator for this. It ends with a 5, so let's check and see. We're going to divide by 5. So that would be a 27. Ooh, and 27, we've seen that a whole bunch. So this would be a 5 and a 27, which is a 3 times a 3 times a 3. Okay? So we've got a 5 and 3 3's underneath the radical. So I've got a pair of 3's. So I'm going to have x is equal to a 3 on the outside and then a 3 and a 5 stuck on the inside. So that's going to be a 15, and remember that's in meters here. So there's our answer. Written in exact form, we're all set to go. Okay, let's take a look at the next one. Again, we're just practicing using the Pythagorean theorem. And we've got an A, we're missing a B, and we've got a C. So this is going to be leg squared plus leg squared equals hypotenuse squared. So this is going to be 36 plus b squared equals, let's see, 14 squared. I think I know what that is. I think it's 196, but let's grab the calculator and just check and make sure. It's 196, so we're in good shape there. 196, we're going to subtract 36. So we get b squared equals, if you do that subtraction, you end up with 160. Now here's the cool thing about this. This is going to be 16 times 10, and 16 is 4 times 4. So rather than break this down completely and get a whole bunch of 2's and a 2 and a 5, we're going to write this. We're going to take the square root of both sides, and we're going to get b equals a 4 times a 4 times a 10. Pair of 4's, so those are going to come on the outside. There's no sense breaking the 10 down because that's just a 2 and a 5, and we don't have any pairs. So this is going to be b equals 4 radical 10. We're going to write centimeters on the end of that. We're going to circle it, and we are done. Okay, next one. We're missing the hypotenuse here, so we're going to have leg squared plus leg squared equals hypotenuse squared. This is going to be 64. Remember, 15 squared comes up all the time for some reason, so this is going to be 225 equals x squared. Let's go ahead and add those together. We could probably do it by hand, or in our head, but let's check and make sure we get this right. Okay, I think I've got that in there right, 289. Now I am hoping that 289 rings a bell. I believe that's a perfect square. So let's just check and see. If we got a decimal answer, then we'd work on simplifying this, but let's check and see. If I do square root 289, hop outside, hit enter, it is. That's a perfect square of 17, and if that's one you recognize, you got a little bit of a head start there. So there, we're going to have x equals 17, and this would be in meters. So 17 meters, and whether you move this around and write x equals 17m or m equals or x 17m equals x, totally okay either way. I do want to point out that as we're going through and solving these are technically quadratic equations. The reason we're not putting a plus or minus on there is because we're dealing with triangle lengths, and they're always going to be positive. Okay, let's take a look at the next one. Ooh, this looks awful, but if I remember right, leg squared plus whoops, make this look right, leg squared equals hypotenuse squared. Leg squared plus leg squared equals hypotenuse squared. And the cool thing about this is these just undo each other. So we get a squared equals, whoops, a squared plus 11 equals, remember, we're going to square this, we're going to get a 3, because if we square root, those undo each other. We get what the radicand, technically, we get what's underneath the radical. And then we get 2 2's, so that would be a 4. So this is a squared plus 11 equals 12. Oh, look how cool this is. We get a squared equals 1, and take the square root of both sides. We're going to write down a equals 1 yard. Okay, that's all it is. Okay, now, whole bunch of work there, keeping track of all those numbers, making sure they work out nicely, and then simplifying the radicals and keeping them in exact form. Let's take a look at these guys right here. So on 6 through 9, it just says determine if each triangle with the given sides is right, obtuse, or acute. So remember what we do here. We look through here and we identify the possible hypotenuse. Which one could be the hypotenuse? Okay, so I'm going to write HYP by that one right there because it's the longest. HYP by that one because it's the longest. And I think they did us a favor here. Every one of these is organized so that the last one is the potential hypotenuse. So let's just check and make sure. So we've got a 5 squared plus 7 squared, and we're going to compare that with 9 squared. So this is 81. That one's not bad. 25 plus 49. Let's see, 25 plus 49. Gosh, if we get stuck, it's a test. Let's just throw this into the calculator. Whoops. 25 plus 49. And I think we're going to come up short. That's a 74. Okay. Now remember, we're always classifying the hypotenuse. Too big. Because it's too big, it is obtuse. We got an obtuse triangle on that one right there. Let's take a look at the next one. Leg squared plus leg squared. Let's check and see how that matches up with the hypotenuse squared. Now this is 144. We did the 14 squared a minute ago. That's 196. And then if we take a look over here, 15 squared, I'm hoping, gosh, we see that all the time, 225. Hopefully that's memorized by now. Now, if you take a look here, this is going to be huge. That's going to be way more than 225. But let's go ahead and find the number. So this is going to be 144 plus 196, and we end up with 340. So 340 and 225. Again, let's classify this. This is too small. If it's too small, that means it's an acute triangle. Okay? Let's take a look at the next one. 9 squared plus 12 squared, leg squared plus leg squared. Let's compare it with the hypotenuse squared. 81, 144, and 196. Again, if you need a calculator for those, go right ahead. If you take a look at this, these are going to add up to be bigger than that right there. In fact, those add up to 225. If you want to double check me, we'll grab the calculator. We'll do 81 plus 144. Or what's even better is if you say, you know what, let's just throw this in the calculator. 9 squared plus 12 squared. As long as you wrote down the work, as long as you wrote down 225 after this right here, you could kind of skip this guy right here and not write that. Either way, too small. So this is acute triangle. All right. And then the last one, we've got a 9 squared plus a 12 squared. And over here we've got a 15 squared. Now we've got a 9 and a 12 here, so this is that 225 again, and this is 225, so we're going to say just right. And if it's just right, then we have a right triangle. Okay. All right, there we go. Now, again, we're always comparing the hypotenuse with those squared legs. So if it's too big, it's obtuse. If it's too small, it's acute. And if it's just right, then it's a right triangle. So on the other side, we're on problem number 10 and 11. It says find the distance between each pair of points using the Pythagorean theorem. Write your answer in simplest radical form and as a decimal approximation rounded to the nearest hundredth. So it actually says use the Pythagorean theorem. So what we're going to do is we're going to make a right triangle. So we're going to go from here to here and from here to here, and we're just going to count spaces. 1, 2, 3, 4, 5, 6. So this is a 6 and this is a 2. And we're going to label that as the distance. So we're going to do d equals, we'll do d squared equals 6 squared plus 2 squared. So d squared equals 36 plus 4. So d squared equals 40. So we're going to take the square root of both sides, and we're going to get d equals the square root of 40, but we've got to write it in both forms, simplest radical form and as a decimal approximation. So this is 4 times 10, which is 2 times 2 times 10. So we got a pair of 2's and a 10 stuck on the inside. So there is simplest radical form. Let's come up with a decimal. And I'm hoping you know that this is going to be a little bit bigger than 6. It's got to be bigger than 6 because it's got to be bigger than either one of the legs. So let's check and see what we get here. Whoops. We get 2 radical 10. So 2 square root 10. Hop on the outside, hit enter. We get 6.324 to the nearest hundredths place. That's going to be 6.32. So 6.32. So both of those are the answer, exact form and decimal form. And then just as a double check, especially if you've got time, what if we did this? What if we did the square root of 40? We wanted to check and make sure that we simplified this, right? If radical 40 really is 2 radical 10, these should give us the same decimal answer, and it does, so we're in good shape there. Okay, let's take a look at this one. We'll draw a right triangle. This is 2. Easy to count those boxes. This is 4. So we'll do d squared equals, I'll go ahead and label that as d. We're going to do 4 squared plus 2 squared, leg squared plus leg squared. 16 plus 4. Interesting. We get a 20. Take the square root of both sides. So we get d equals the square root of 20, and that is a 2 times a 2 times a 5. So we get 2 radical 5. So there's the exact answer, and here's our decimal approximation. We'll do 2 square root of 5. Hop outside, hit enter. Okay, so we're in good shape there. 4.472. That 2's not enough to bump it up, so this is 4.47. 4.47. So there's our approximate answer. And then we'll do that one last double check. We're going to hit square root, and then we're going to do the 20. And we're going to hit equals. Yep, same answer either way. And again, if this is 4 and this is 2, we should expect that to be a little bit bigger than the bigger of the two legs there. Okay, distance formula says you got to use the distance formula here. Same ways to write the answer, simplest radical form and as a decimal. So distance formula, remember, is d equals big square root, and then it's going to be x2 minus x1. x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So if it helps, go ahead and write down a big square root. Write down each one of the quantities that we're going to have and put those negatives in between there. x2, 5, minus x1, 8, y2, 3, minus y1, negative 2. So this is going to be, and again, you can drop the radical for just a second. This is going to be negative 3 squared. This is going to be a plus. This is going to be 5 squared. So this is going to be 9 plus 25. And we end up with, this is kind of cool, square root of 34. And the cool thing about 34, it's only a 2 and a 17, no pairs. So this is the exact answer. Let's throw it in the calculator and get a decimal for that. Square root of 34, and we'll hop outside, hit enter, 5.83. So 5.83, and that doesn't round up either, so 5.83 approximately. Okay, let's take a look at the next one. I'll go ahead and write this down. big square root. I'll put the quantities that we're going to square with a minus in between, and then we're going to do x2, 7, minus x1, which is 3, y2, which is negative 4, minus y1, which is negative 12. So careful here, that's going to be a plus. So this is going to be d equals a big square root. This is going to be 4 squared. And this is going to be 8 squared. So neither one of them turn out to be negative. We're going to square them anyway, so let's take a look and see what we get here. So this is going to be d equals 16 plus, this would be 64. 8 squared is 64. So we get d equals the square root of 80. Now let's go ahead and simplify here. Let's see what we get. This would be, let's say, 4 times 20. So this would be 2 times 2. And this would be 2 times 10, which is 2 times 5. So wow, look at all these 2's. We've got 4 2's, which means, so let me go ahead and write it this way. 2 times 2 times 2 times 2 times 5. Pair of 2's here, pair of 2's there. Now if you can write down 2 2's would be a 4. 4 radical 5. And circle that right from here. You could probably skip that step in between. And then here's our approximate answer. We'll throw that in the calculator. Let's see what we get here. 4 square root 5. Hop outside, hit enter. 8.944. So again, we don't round up. 8.944. So it would just be 8.94. And then here, let's see, as our double check, what was that, radical 80? Now I've got a good suspicion that this is right, because if we did radical 81, it would be exactly 9. So radical 80 should be a little bit less, and look at that, it's the right answer right there. Okay, let's take a look at this last couple here. So we're going to be solving these in context. And it says draw a picture to represent each situation, so we'd want to do that. Then use the Pythagorean theorem to answer the question. So again, a ladder problem here. 6 feet from the wall. If the top of the ladder is 8 feet up on the wall, how long is the ladder? So a little bit different than we had before. So we've got a ladder here, and this is what it gives us. It's 6 feet from the wall. The top of the ladder is 8 feet up on the wall, and the question here is how long is the ladder? So I'm going to use x for the ladder, and it's going to be leg squared plus leg squared equals hypotenuse squared. So let's see, what have we got here? 64 here, 36 here equals x squared. 64 plus 36 is 100. Take the square root of both sides, so we get x equals 10. So what that means is, how long is the ladder? The ladder is 10. So we'll say ladder is 10 feet long. Okay, so there's our answer on that one. And let's take a look at this last one. A football field is a rectangle 55 yards wide and 120 yards long. The coach asks the players to run from one corner to the corner diagonally across the field. How far do the players run? Okay, and this is actually true. A football field is 55 yards wide, and it's 120 yards long, including the end zones, and the players have to run from here to here. So the question is, what is that distance? Well, that distance squared would be a leg squared plus the other leg squared. So this is going to be 120. So d squared is equal to, we'll take the square root of both sides. Yep, let's go ahead and do that. So we get 55 squared plus 120 squared. Now this is a story problem, so this is where the calculator is going to come in really useful. There's no need to find out what this is squared or that is squared and then add them together if we can have the calculator do all of this. So here's what I'm going to do. I'm going to hit a big square root. We're going to do 55. We're going to square it. We're going to add 120, and we're going to square it, and then we're going to hop outside. So we're going to hit enter. So we get 132.00. So gosh, to the nearest hundredth, it's 132 yards. So this equals, and we're going to use an approximation symbol right here. So we're going to do 132 yards. Okay, so the question was, how far do the players run? They run 132 yards. Now, just to double check, if you were to square this, if we were to square 55, you get 3,025. If we squared 120, 12 squared would be 144, and then we'd have the two zeros after that. So if we add these together, this is 14,300 plus, 14,400 plus 3,025. If you added those together, you would get 17,025, okay? 425, yeah, 425. So if we took the square root of that, we should get the same thing. So let's just check and see, just for the heck of it. So we'd hit second square root, square root 17,425. Hop out, hit enter, and there's our 132. Okay, so same answer either way. Great practice problems. Make sure you do this as many times as you need to. Make sure you ask questions if you've got them. Got to have some good scores on this test. All right, good luck.